Hi, we continue with the chapter 7 part 2. Okay, let's have a look at that. We are going to continue with the asynchronous stun counter, alright, and also we look into the propagation delay in the ripple counter, and we have to look at the decoding part, and also we look at the decoding glitches and some IC register. Okay, have a look at this. This is a asynchronous stun counter. This is very similar to the one we learned before, right? The clock come in here, but the only difference is they use an inverting output to connect to the clock. Inverting output to connect to the clock, right? So it will count down. Yeah, that means 7, 6, 5, 4, 3, 2, 1. Okay. So this is the mode 8 state diagram countdown counter, right? Is a 0, 7, 6, 5, 4, 3, 2, 1, 0. You can see that in these directions. Okay, let's check it out. I want to show you the diagram. Okay, now remember, this is the clock input. A is the output, and then we inverting input fit into the clock. This B is depends on the inverting output from A. This C is depends on the inverting output from B. All right, let's check it out. This one we understand very well. A depends on negative trigger, right? Okay, right, fine. You look at B. B is depends on the this one, right? The negative trigger from the A bar, right? You see it? Okay, let me get a pen. Let me get a pen. Get a pen. Now, okay, you look at this A. If the inverting, okay, A bar will be what? The bar here, right? See that? So this guy is A bar. Are you with me? So my B is depends on the negative trigger of the A bar. You can see here, trigger, here trigger, right? Negative, right? Here trigger, and so on. So in a way, B is really looking at the A positive trigger, correct or not? So here we go. Same thing for C. Let's say if you draw the B, you draw the B bar will be the opposite, right? Opposite, right? So at C is depends on this guy lah, right? B positive, B positive, B positive, and so on. You look at the counting sequence, right? Look at the counting sequence. 0, 0, 0, 1, 1, 1, right? You see? This one, 1, 1, 0. This one, 1, 0, 1. 1, 0, 0. And up to 0, 0, 0. And then repeat. So we can see it's a down counter, right? Any problem with that? Very straightforward, right? Now, we have to look at this one. We have to decide a circuit to turn on the LED for 1 second. Every 13 seconds. Okay, every 13 seconds with the turn on the LED for 1 second. Because that is to signal the assembly line worker to perform some manual operations. Assuming a 1 Hz clock is available, how do we do this problem? Okay, let me show you the answer and explain to you. Frequency is given to you at 1 Hz. So what we have to do is we need a divided by 13 counter, right? That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we repeat. All together we got 13 count, right? Okay. Every count, let's say from 0 count to 1, the time it takes is 1 second. Every count it takes 1 second. Are we good? Have a look. So this is the way to decide the mode 13 counter, right? So you ask yourself, mode 13 counter, you need how many bit? You need 4 bit, right? I'm giving you a 74293. I got a mode 8, which is 1, 2, 3. This is a mode 8. Also a mode 2, one single flip-flop on its own Q0. So you have to connect them into 4 bit. So the Q0 now is connected to CP1, right? You feed your frequency from Q0, right? 13, right? You know what is 13? 13 is 1, 2, 4, 8, right? So 4 and an 8 and a 1, add them up together, 13, right? So the bottom line is, I told you, you got this 3 run, right? 1, 13 is what? Let me, you have this, what? 1, 1, 0, 1, right? 13, right? 1, 2, 4, and 8, right? 13, right? The bottom line is, as long as you have this 1, 1, 1, by hook or by crook, you just make sure your MR1, MR2 also 1 and 1. As simple as that, right? For the sake of argument, you say, oh, sir, I don't want to put here into Q, I don't want to put this bit into Q2, I don't want to put, you can use a 2 input AND gate, monitor 2 and a 3 lah. Then the Q0 into the, either go to the MR1 and MR2 lah, it's okay. As long as this 3, 1 is equal to 1, this 2, 1 also must be equal to 1. You can use any logic circuit to implement that. It's okay, very straightforward. So we have a circuit here as mode 13, right? Here you go. So how this thing work? Let me show you. You see from here, 0, 1, 2, 3 until, okay, when it count to 12, the next count is 0, 0, 0, 0, correct? This is all together 13 count, right? Are we good? Okay. What you have to do is, when they count to 12, 0, 0, 1, 0, 0, 1, 1, 0, 0, when they count to 12, right, then you monitor this. When they count to 12, okay, you go and turn on the LED, right? So because from 12 to 0, the time it take from 12 change to 0, the time it take is 1 second. So that's why you got, when they hit 12, you turn on the LED, it will hit 0, right? So the time it take will be 1 second. When it hit 0, 0, 0, it will go back to, okay, 0 to 12. When it hit 12, go back to 0, and so on. All right, any issue? Now, how this thing work? Q2, Q3, Q1, Q. Okay, you see that? Q2, Q3. Do you see this is a Q1 bar, Q0 bar? Connect to the 4 input AND gate and connect to the LED and turn it on. What does it mean? Let me explain to you. It's very straightforward. Now, you see, for any flip-flop, let's say this is a Q, this is a Q bar, right? Right, correct not? If this joker is a 1, this is a 0, correct not? Same thing, let's say you got another flip-flop, this is called Q, this is called Q bar. If this guy is 0, this guy has to be a 1, right? Correct not? So you know what we do here? What we do here is Q2, Q3. Yeah, okay, you connect to Q2 and connect to Q3. This one, okay, what is our count? Our magic number is 1, oh, I beg your pardon, 1, 1, 0, 0, which is Q3, Q2, Q1, Q0, right? So Q2, Q3, Q2, you connect to the input here. What about this Q1 and Q0? At that time, Q1 and Q0 equal to 0, 0. Am I correct to say they are inverting output? Their inverting output is equal to 1. This guy also, their inverting output is equal to 1, right? So when that happens, it's 1, 1, 1, 1. Am I correct? This is a 4 input AND gate, right? So the output here will be a 1. So your LED will turn on. Got it? When it's 1, 1, 0, 0, LED turn on. Turn on for 1 second because the next count will be 0 already. Right? That's it. As simple as that.